Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 1.8, day 1, entitled Coordinate Geometry. And we're going to talk about the coordinate plane today, so that'll be a little bit of a review. We'll talk about the distance formula and the midpoint formula. I think we'll actually save those for tomorrow, mostly. We are going to talk about graphing in two variables a little bit today, and then how to find x-intercepts and y-intercepts. So we're going to kind of focus on those three today. Okay. Now, remember that when we are graphing, we have a system on which we can graph, and that's called the Cartesian coordinate plane. It's named after an old dead math guy called René Descartes. He was a French mathematician and philosopher, and he came up with this system for graphing. And we have the x-axis and we have the y-axis. You have the origin, and you have positive and negative points. Okay, so you have your x-axis here, your y-axis here, up and down. X-axis goes left and right. The origin is the spot in the middle there, 0, 0, where the two axes meet. As you go to the right, you have positive values. As you go to the left on the x-axis, you have negative values. As you go up on the y-axis, you have positive values. And as you go down on the y-axis, you have negative values. So the coordinate plane gets divided into 4 quadrants, and they go counterclockwise when you're numbering them. We use the Roman numerals to number them instead of the traditional 1, 2, 3, 4. And any point on the coordinate plane is called an ordered pair, and it's represented by the numbers a, b, or you know them more familiar as the ordered pair x, y. So the first value is the x-coordinate, second value is the y-coordinate. Okay, so any point in the coordinate plane that's kind of like an address for a location on the plane. Okay, so after that quick review, we're just going to also graph a couple of regions here. So this is dealing with set notation, and it's dealing with graphing. So for part A, they want you to graph all of the values for x and y. That's kind of what this means here. They want you to graph all the values for x and y such that x is greater than or equal to 0. So if you think of your coordinate plane, think where x is 0. Now your x-axis goes left and right. Your value for 0 is the origin there. So we want everything to be greater than 0. So if this was just the number line, we would shade everything over to the right. But since we also have our y-axis in there as well, we need to shade everything to the right of that y-axis, because basically that y-axis is the line x is greater than or equal to 0. And since it's equal to, we want this to be a solid line here. If it wasn't equal to, if it was just greater than, we would have a dashed line. And we'll talk about that in part C. Okay, for part B now, they want us to graph all the values for x and y such that y is equal to 1. Oh, so now you have basically a line. Y equals 1. That's what they want you to graph. Okay, so on the y-axis, your value for 1 would be here, and they want you to draw that line. They want you to draw all the values where y is 1. Okay, so you have a horizontal line. Remember, horizontal lines have a slope of 0. Okay, now part C, this one, due to the font style, looks a little tricky. But again, they want you to graph all the values for x and y, and then this is the line such that the absolute value of y is less than 1. So remember, when we're dealing with our absolute value inequalities, we really have two cases. We're going to have y is less than 1, and we're going to have y is greater than negative 1. So I'm actually going to have two lines that I'm graphing on my coordinate plane. So here's one on the y-axis, and since it's just less than, I'd want a dashed line. And negative 1 on the y-axis would be down here. And again, since it's just greater than, I would have my dashed line. I wanted everything less than 1, so that's everything below that dashed line, and everything greater than negative 1, so that's everything above the other dashed line. So the part that overlaps is this shaded region in between them. So it ends up kind of looking like a little sandwich. So you will see some problems like this on your homework where they just want you to review these basic concepts of graphing, and they're helping you review set notation as well. Okay, so now we're going to graph equations that have two variables. And this is what you're very familiar with. You have an equation that has an x and a y in it. And they could have in this case, a quadratic relationship where you have y equals x squared plus 1. Our next example is going to be a linear relationship. So that would just be y equals x plus 1. If it was linear, you're not going to have the x squared. And basically when you are graphing that line, you're finding or plotting all the points that satisfy that equation. So it's a visual representation of all the answers that satisfy that equation. Okay, the book defines the graph of an equation. The graph of an equation in x and y is the set of all points in the coordinate plane that satisfy the equation. Okay, now when you go to graph a linear equation, when you were a freshman, you learned how to make a table of x and y values. You substituted some numbers in, and you got some numbers out. You plotted some points, and you connected your points together to make your line. But we're more sophisticated than that. We know that this right now is in standard form. That's your ax plus by equals c. So that's your standard form for a line. And that's really good if you're trying to find the x-intercept or the y-intercept. Standard form is really good for that. But for graphing, the best form is going to be slope-intercept form. And that's basically where you solve for y. And the reason we like slope-intercept form is because we can look at the equation and we can tell what the slope is and what the intercept is, and then we can use those two pieces of information to graph. So in order to get it into slope-intercept form, I have to solve the given equation for y. So I'm going to subtract my 2x over. So that gives me negative y equals. Now I want the negative 2x to actually come first, because slope-intercept form, remember, is y equals mx plus b, where m is your slope and b is going to be your y-intercept. That's why we call it slope-intercept form. So even though I could write 3 minus 2x, it's more appropriate and closer to the finalized slope-intercept form if I put that x first. And then I just need to go through and I need to get rid of that negative in front of the y. So I have to divide by negative 1 or go through and change all my signs on every term. And there is my equation in slope-intercept form. So my slope would be 2, and my intercept is going to be an ordered pair. It's going to be 0, negative 3. A lot of times we get a little lazy and we just say my intercept is negative 3. But remember, it's an ordered pair. And your slope is actually rise over run, so this is actually 2 over 1. So I would start by graphing at 0, negative 3, and then I would go up 2 units and over 1 unit. And that's what is shown here in this graph. They're starting at 0, negative 3, and they're going up 2 and over 1 and plotting a point. Up 2 and over 1 and plotting a point. And you can continue that pattern as much as you need. You can also backtrack. You can go back to negative 3, and you can go down 2 and back 1. So that's a useful skill to be able to have if you're running off the edge of your graph paper, for instance. And the book also has this table of values. You do not need to make a table of values to graph this by now. I know that you're sophisticated enough that you can find your intercept and plot your slope and make your line that way. Now the last thing we're going to talk about for today is the concept of x-intercepts and y-intercepts. And intercepts is just basically where the graph crosses either the x or the y-axis. So your book has this nice little table, and it kind of summarizes the definitions of the intercepts. Your x-intercept is the x-coordinate of the points where the graph of the equation intersects the x-axis. So here's my x-axis in this little picture. I have 1 intercept, 2 intercepts, 3 intercepts. So my intercept then would be that point, that ordered pair for that point. And we can find that based on an equation. We don't have to read it off the graph. And when you are trying to find the x-intercept from your equation, you plug 0 in for y, and you solve for x. And to find the y-intercept, you reverse it. You plug 0 in for x, and you solve for y. So those two pieces, I think, are the most important part of this table. And it also defines the y-intercept. This is where the graph of the equation intersects the y-axis. So if you look at your picture, it has 2 y-intercepts that are shown. Okay, so example 7 then says find the x and the y-intercepts for the graph. So if we're going to find our x-intercept, remember you plug 0 in for y. So it's kind of opposite. If you're finding the x-intercept, you plug 0 in for y. So 0 equals x squared minus 2. Now I just have to solve that for x. So I'm going to add the 2 over to the other side. So 2 is x squared. And then to get rid of the squared, I have to take the square root of both sides. Remember when I physically do that, when I physically take the square root of both sides as part of my solving process, I get a positive or negative value. So my x-intercepts are going to be negative square root 2, 0, and positive square root 2, 0. I know the y value is 0 because I substituted in 0 for y. Then to find my y-intercepts, I'm going to do the opposite. I'm going to plug 0 in for x. So I'll have y equals 0 squared minus 2. Well, 0 squared is just 0, and 0 minus 2 is negative 2. So my y-intercept is going to be 0, negative 2. And I know that the x value is a 0 because I substituted in 0 for the x. So there's my 1 y-intercept, and there are my 2 x-intercepts. So remember, this equation, since it's x squared, remember that's going to be a parabola. It's going to open up. So it's going to cross the x-axis at negative square root 2 and positive square root 2. And it's going to also have a y-intercept, or it's going to cross the y-axis at 0, negative 2. So if we needed a visual representation of that, it might look, something like that. There'd be negative square root 2, positive square root 2. There's 0, negative 2. Oh, and there's the pretty book picture. Much nicer than my picture. But again, it's marking the x-intercepts on the x-axis and the y-intercept on the y-axis. So there are your practice problems for this evening. Definitely review those problems. And if you have any questions, come on in and see me.